I'm going back. No, no, no. So yes, so basically we do our SolidWorks, and you wouldn't hear this from civil engineers, but mechanical engineers will talk about that. Then afterwards we have to fabricate. So we designed a simple thing. If I'd known you, we would have helped us with our design. Instead of using steel plates, we probably would have used some fibers, because we realized in our design, after heating to about 350 degrees Celsius, we lost almost all our stuff in the chamber. So maybe there's help that we can get from that. We look forward to collaborating with you. Thank you very much.
All right, thank you very, very much. Um, hold on. So basically, we are done with the presentation. So let's clap for all the presenters. Now it's time for questions and answers. So the floor is open. We have, I think, 5 minutes or so to do questions and answers. Then we will have our lunch. Okay. All right. Please, let's acknowledge Engineer Dr. John Kwesi Kwam Jr. from UCC. Where is Doc? Oh, okay. Are you sustainable? Which department, please? Okay, okay. From development office. You're welcome, sir. Stand. All right. So, my lady, where is HOD? Question from the lady. Okay. So I think it's better we line up, right? So we have a fair idea. So please, let's line up. One, madam. So, and then anybody who has question, please line up so we have a fair idea of those who are going to ask the question. Oh, are we done? Okay. All right. So, okay, our HOD will ask the first question.
So when I saw some of the slabs that were being casted, how were you able to or move them from the cast? Because they look big. Some of them I think most of them had slabs. All those. How do you move? Oh no, so that's not pro. How do you move those slabs to the test bed or to the lab? And how sure are you that during the movement you don't have movements and other forces and on the slab, so you can affecting the integrity of the slab?
Yes, it was very difficult to move because the slabs were 1.2 by 1.2 100 thickness. So unfortunately for us in this country, we don't have equipment and stuff in our labs. So we have to do manual lifting. So you actually pay people from outside to come and help lift them onto the frame. We have those slabs because that is the setup that is available in the lab. We would have casted smaller slabs, but the setup is 1.2 by 1.2. So you are limited to that side, and you need to pay people to come and help lift it for you.
But please, we have the equipment too. We have them. We will take you to some our campus. We have the equipment you don't have. The next question, please.
Please. Good afternoon. My name is Imanaya Owusu. Please, my question goes to all the presenters. Please, when they were presenting, they were talking about when it comes to contact with fire, there will be an issue, but they were all talking about the cover, or concrete cover, or yeah. Please, do they have any recommended cover size that we should use, or we should normally use the old type that we use, the 50 mm? That's what I want to know, please.
Okay, the concrete cover with a normal steel is not even one size. It's not 50. For steel,
we have three exposure levels, right? We have the severe, the then we have the moderate, and mild, right? Severe is where, let's say, corrosion and so on, very severe. So it's not only 50, right? It's not only 50. Depends on the exposure of the structure or the building to the environment. So let's say corrosive environment, right? But coming back to the DFRP, as was mentioned, but in terms of fire resistance and so on, uh, the greater the cover, the better the protection to the DFRP. The DFRP is it's not much about corrosion, but more about fire, right? Because DFRP doesn't corrode. So when we are looking at fire, is the cover is with respect to the fire. Is that right? But there a lot of we need more research in that area because it's not exhausted yet. So we don't have a definite say 50, 100 or whatever, right? Because more research is needed. And then when the presenters made their presentations, first to do fire resistance, you actually need a member carrying a load according to the codes. You need a member, structural member. So you apply the heat, and then you measure the resistance together with the displacement deflection. So it will be both resistance, strength, and then deflection. That is what is going to indicate the fire resistance. And as I'm saying, more research is needed in that direction. So I can't tell you right now that you get.
Thank you. Thank you, Prof. Next question.
Okay, my name is Mashif Toibat, a civil engineer student in Accra Technical University. My questions are: How can punching failure be prevented between concrete and PRP? No, it's not GI. It's FRP. That's the yes. Okay. GRP affects overall beam performance.
Thank you very much. Punching shear. How do you prevent punching shear? And then the bonding.
Yeah, okay. For punching shear, we introduce vertical reinforcements in the slab. That is what we call the punching reinforcement. So when you have a slab, you may want to use sand coated and ripped. In some countries, the bars are either sand coated or ripped, but we have a combination of the two. I'm a researcher, so so Viva Bars, for your benefits, performs better in bonding than bars in other countries because of the combination of the two effects.
Thank you so much. The next question, please.
Please, my name is Ethel A.C. Akins, a civil engineering student. Okay, so my question is, we have this fiberglass and it have long lifespan, yeah, and we have our normal rail and finding them together to work. So my question, this is where my question comes from. So what will happen when the reinforcement bar, our normal reinforcement bar, okay, steel bar, it corrodes? Yeah. What will happen?
All right. He's talking about.
Yes, it's a very good question. First of all, thank you for pointing out about traditionality. The traditional reinforcement, as from the very beginning was said, it was bamboo. Bamboo reinforcement is more traditional than the. Sorry, who is the one and why?
Yes, I'll be very brief. So with regards to lifespan is the application, is the places, and about the economy. You do the calculation what works better, because I mean, as Viva, we support slabs. Slab is the most exposed place for the corrosion because the concrete cover is the least. On the beams and columns, you have more concrete cover, and it is less exposed to moisture, salt, and the rest of things. In case of roof slab, you have rain and water stays on the slab, and the risk of penetrating the concrete is much higher. As simple as that.
No, no, no. I just want to add, address your comment. The use of the word lifespan. See, you don't have anything like lifespan for steel or lifespan for DFRP. Do you get my point? It's when you have used it to design, let's say a building, or if you've done a bridge or a road, they show the lifespan of the road is 25 years, lifespan of the road 15. But the uh, steel, steel on its own, or glass fiber on its own, doesn't have a lifespan. Are you getting me? Do you get it? It's when after you have used it, maybe in construction of a building structure, that will say, oh, the lifespan of this brick is maybe 50 years. That is a following usage of it. Look at the usage can be maybe it have become under let's say the load, for example. It may exceed its loading right value. So you can say that maybe the bridge it can take so much load at this time. Maybe in 50 years' time, the load would have increased so much that it's no longer useful. That's why we say last one, last one. But if we say steel doesn't have a last one.
Thank you so much.
Good afternoon, to all. My name is Fawaz, and I want to stand here and thank our engineer from electrical department who has stood out to support us as an electrical. And I want to ask a question about the GRPT that we have been discussing about is having a last one. We are having a transmission line that is going on, and we have a tower lines that have been earthed, and we know this one doesn't have a lifespan. Is it that we can use it as an earthing rod so that it can corrode in future?
That's a brilliant question. Fiber does not conduct. You get it? It doesn't conduct. So if you are using, why do you do earthing? For conduction. Am I right? But this cannot conduct. So when you use it for your poles, many times we try to ground the pole. So when you use it for that, you might forfeit the grounding because there's no conduction taking place. Is that clear?
But can't we have a hybrid one where you put the one that will conduct inside the hybrid, so we have a protective cover with the fiber? Think about that too.
Thank you. We'll work on.
Good afternoon. Please, my name is Kelvin. I'm from the mechanical engineering. Please, my question is, as comparing the fiber or comparing this item to steel, we know that applying heat to a certain temperature increases the expansion of the steel. So let's say as if I extend a temperature on this material, will it increase the expansion of this one? Or it will remain the same?
So expansivity. Somebody did
Hello.
basically talking about expansivity coefficient.
Okay. Hello. Yes, so that is a very good question he has just asked. And the thermal expansivity, or the concept of the Viva bars he was asking inside the concrete upon subjecting it to heat, is the sense that when it is heated, the concrete itself expands and grips tighter on the fiberglass rebar, making it more rigid and more efficient in performance.
All right. You said what? Okay, you asked briefly.
Okay, please. If I'm able to weigh this one in my hands, comparing it to the weight of the steel is much heavier than this one. So I want to predict that if so far as I place the steel on water surface and the steel is able to sink, then what about if I place this one on the water surface? Will it be able to sink? Actually, so meaning the density of the I want to actually know the density of this item. Actually know the density of this item.
So the density is no. Okay. So the density is no. Okay. So this. So this. Do you understand? Do you understand? No. So don't worry. This the specification brochure. When you check the brochure, so all these things they have the specifications. Yeah. Thanks.
Some of the materials combined to do it. And then my second question is, looking at my research, the steel is.
All right. So I think his question is the coating that we have on it. What's the composition of the material, the constituents?
Yes, basically it's silica. It is coated with sand and the epoxy resin. Mainly, it is 90% silica. We have done the chemical composition test in Nairobi. Unfortunately, in Ghana there is no laboratory which is doing chemical composition, which is also silica, which is also sand. And sand is there serving in two purposes. First one is to improve the bond purposes. The second one is to improve protection from UV, from sand. Because when it is exposed to the UV, epoxy resin becomes crackable. It becomes very brittle. And sand is absorbing the UV.
Thank you very much, Mr. Ivan. So we take the last question. But the thing about the densities, I think we've made it.
Is there any institution here in Ghana currently involved in the manufacturing of the Viva steel bars? And is it allowed, or as students, can we go for internships there? Thank you.
Yes, please. Thank you for this question. Ghana is the first country on the continent of Africa who has adopted its national standard in 2018. I'm happy. We even have a member of a technical committee over here who was part of this team who adopted the first Ghana national standard in Africa. And yes, it is manufactured according to the Ghana national standard since 2017. And Viva is the only manufacturer in Africa which is licensed according to the national standard to manufacture it. Furthermore, Viva is not the scientific colleagues to be calling it Viva because it really has different parameters than normal GFRPs. GFRP, the name appeared some 80 years ago, and there are so many different types of GFRPs, and they are really different in terms of strength, bond, composition, and the manufacturing type. Thank you.
Fortunately, we have the rep from Ghana Standards Authority, so let's listen to him.
Thank you very much. I'm Festus Nayan. I have a comment and a question. Right. The first comment is when one of the students were presenting, he made mention of comparing Euro code, Indian code, and then the ACI. I didn't hear of the Ghana Building Code. We have that available at the Ghana Standards Authority. So I'm suggesting in your next question is, in fact, so it will be my first question. I want to know the material to use in the binding when you were conducting your research. After you've arranged your fiber bars, what materials did you use to bind them before you did the casting?
Yeah, is the binding, we use a normal binding wire still, so to bind it together. So we can say that is also a hybrid. Right, we use it. So I forgot to add that I'm a past student of this institution and I'm proud coming back home.
No, it's a word of question. Word of question. All people.
Okay, my name is Raymond. I would like to give this word of caution. In as much as we are trying to promote GFRP, it is appropriate that we take engineers' advice before we apply them. One thing about marketing, someone may use the same product and use it wrongly. Immediately there is any catastrophic situations, that business is gone forever. So it's appropriate we take advice and then engineers' directions before we apply them. Thank you.
All right. So we'll take the last question and then a comment from the member of the technical committee then that helped that approved the GFRP from Viva.
Thank you. During the presentation, one presenter gave his presentation on reusable bars. Am I right? Yes, my interpretation is that the bars have been retrieved from a prior construction. I want to get it right. Is that so? Okay. If it is so, then I think that some criteria has to be established as to the extent, by all means, when you retrieve, there will be some damage to the bars. There has to be some criteria established beyond which it may not be advisable to reuse, or for you to add some mitigating techniques to make them effectively reusable. So that is my question, which you answered, and that is my comment after the answer. Thank you.
Thank you very much. So we'll take the closing remark. And ask, okay. Prof, can you? Okay, so it will be part of your closing remark. Let me see. The closing remark.
I think correction with the reuse bar. That's your question, right? There should be a benchmark.
Yes.
There should be something to indicate.
It took 20 years before you took, or 10 years, and then something happened to it.
No. Even today, if it's retrieved today, is there a loss of strength or something like that, isn't it? Because it has been used in a structure, you have retrieved it, there might have been some loss, either in strength or in some other property there. But after retrieving, the specimens were taken from the retrieved part and studied again as if they were new. So that the various mechanical properties were studied and were found to be about the same as the original. right? There were no significant losses. They were about the same. Is that right? So the reason is that, see, the strength rate of GFRP bar is fully linearly elastic to failure, straight line, and then you fail suddenly. Is that right? So if in a building the a bar is retrieved and the bar has not ruptured, it means it is still in its elastic behavior. And so once it is elastic, any load that comes on it, if when the load is removed, it will return to its original position. There will be no deformation built in it. There will be no permanent deformation in it because it is perfectly elastic. Unlike steel, which is elastic, inelastic, and plastic. If you want steel and a normal building, normal structure, the steel may be in its inelastic domain. So when you remove the load, there will be a permanent deformation in it. This is completely different from GFRP. Is that right? This gave the indication that the bars, once the bar is not ruptured, then anytime it is not ruptured, it can be reused. That gave the hint to investigate reusing a GFRP bar that has been previously used in a structure and the structure is demolished. So a test was done up to failure of some slabs and the bars were retrieved and they were tested. They were tested for their mechanical properties and also tested for their embedment in concrete. And there were no difference at all in the both aspects.
It's probably just an addition. For if you look at steel bars, let's say retrieved steel bars, for some, if you go through the history of its usage, especially if there has been some fire or if there has been some exposure to some temperatures, sustained temperatures above maybe 600 degrees or so, in which case the recovery, there's loss of residual strength. But in case of GFRP bars, you may have the changes in the structure of the resin, in which case it becomes dangerous to reuse. These are areas which the researchers have got to, help us so that the end user, I am a member of the technical member. I'm also an end user, and I use these things. So these things have got to be clear so that we march forward.
Thank you, engineer. Yeah.
I think, engineer, here we are talking about normal temperatures because elevated temperatures, those are different environmental issues. But in any case, if the structure has been exposed to high elevated temperatures, you still need to test maybe the bars, whether GFRP or C bars, to see whether they have lost their mechanical properties before we can reuse them. But the point is, we are talking about normal temperatures, no ambient temperature, not elevated temperatures. I hope that answers it right. Further remarks. Okay. Okay. So my first word will be thank you to everybody who has decided to be here today. This symposium or this meeting initially was programmed for KNUST, to have it at KNUS because we have a visitor, a guest from Kenya. He wants to be in Kumasi. In fact, he will still go. We'll still take him there. But looking at, considering my graduated students, most of them are here, PhD, M3, and so on, and then continuing MSc, M3 students, most of them are in Accra. The MSc and the M3 students, normally they take their taught courses at the weekends, Saturday and then Sunday. So I'm sure those who are here will leave for Kumasi tomorrow. And having said that, initially we wanted the program to have been tomorrow, but because they have to leave for Kumasi, as I'm saying, most of them are here. We wanted to catch all of them, graduate students, continuing students, mostly living at Accra, to be in attendance. So we decided to shift it to ATU, because ATU is like the brother or is the sister of KNUS. Not a baby, brothers or sisters. But we are okay, both brothers and sisters of. No, I don't want to. Yeah, no, it's sister, but I also want to talk about men, brothers and sisters. So brothers and sisters. And so I discussed it with Mr. Jonathan Sasa. He's here. Jonathan Sasa. Then Mr. Spicy. Because they are my PhD students doing Kumasi. I said, what is there a possibility of having it done here? Oh, well, the first time I came here, said 2 years ago, but that was last year. I was very impressed with everything that went on here at ATU. So, as a matter of fact, everything that we are going to have in future about Viva, that's about, I will suggest to him that we have it here. So I want to thank the organizers, starting with Sasa Spicy. Okay, I'm calling him because he's called Richard Ekuokon, right? Yes. So they have organized so well, and then so they were the instruments are used more or less, but they discussed with the the head of department, the dean, and so on. So they have done so well. But the time was short. No, time of notice was very short, but they've done extremely well within a matter of about a week or so. So as far as I'm concerned, this has been a very, very successful event. So on behalf of KNUSU, then I know he will also thank you, but on behalf of Viva, I want to express our gratitude to the staff and management and staff of ATU, particular reference to Vice Chancellor, Vice Chancellor, Dean, HOD of Civil, and then I think we have also had a mechanical and so on, and then faculty members and students of ATU. We are very, very grateful to you. It has been very interesting. So that gives confidence that Viva DFRP. Very soon will be the reinforcing material that we are going to use. And we are talking only about reinforcement in concrete, but I just heard from electrical, mechanical, they are all interested. Electrical mentioned a hook, fan hook for fan. I know Viva initially said, no, it cannot be used, so it can be used. It can be used. So we will research into that. So electrical, we will use glass fiber as hooks for our fans. And then mechanical too, we are going to work together in collaboration. So I want to thank all of you, everybody here, those who came and have left. Thank you so much. You have a pleasant day.
All right. So we're going to take some pictures before we leave.